Solve problem 1.1 Charged balls. Two identical charged balls hang from the ceiling by insulated ropes of equal length L equals 1.50 meter. A charge Q equals 25 microcoulomb is applied to each ball. Then the two balls hang at rest and each supporting rope has an angle of 25 degrees with respect to the vertical. What is the mass of each ball? So here you have two identical balls. They both have the same mass and the same charge Q, which is given as 25 microcoulomb. Microcoulomb you can write as 25 times 10 to the power negative 6 coulomb. They are both suspended by ropes of length 1.50 meter, and these ropes makes an angle of 25 degrees with the vertical. We need to find what is the mass of each ball. So before we solve for masses, we need to find what are the forces acting on these balls. And since they are identical, I can find forces acting on just one ball and solve for its mass. So let me call this ball 1 and ball 2. We will find all the forces acting on ball 1. The first force that we are going to discuss is the force due to gravity, which is acting vertically down. And we write this force as Fg. The second force acting on ball 1 is the electrostatic force of repulsion because of 2. Since both balls have the same charge, they will repel each other and ball 1 will move to the left because of ball 2. So we will call this force Fe, which is electrostatic force of repulsion between 1 and 2. Since the ball is suspended with the help of a rope, there will be a tension force acting along the length of the rope directed towards its suspension point. So we can show the tension force like this and we call it T. Now this tension force makes an angle theta with the vertical as it is along the length of the rope and the rope is making an angle theta with the vertical. Tension force is neither on the x-axis nor on the y-axis. So we have to split this force into its component. One component that will go along the y-axis, which we will call t cosine theta, and one component along the x-axis, which we will call t sine theta. Now, usually we take the x component as cosine, but here we are taking y component as cosine because the angle theta is adjacent to the y-axis. It is not made with the x-axis, and we know that cosine is a term that goes with the adjacent side. So here my y-axis is adjacent to the angle theta. So y component of tension we are associating with cosine theta. So these are all the forces acting on ball 1. Both ball 1 and 2 are at rest as it is mentioned in the question. And if an object is at rest, the net force acting on that object has to be equal to 0. So we are going to equate both x and y component of net force acting on ball 1 to be equal to 0. So let us start with the x component. I write F net x to be equal to 0. F net x is the vector sum of all forces acting on the x-axis. On the x-axis, we have force T sine theta and Fe. Since T sine theta is going to the right, we take it positive. Fe is going to the left, so we take it negative, equals 0. Move Fe to the other side, you get T sine theta equals Fe. I will call this equation 1. We do the same thing for forces along y-axis. We write F net y to be equal to 0. Along y-axis, you have T cosine theta and Fg. So we write T cosine theta to be positive as it is pointing up. Fg on the other hand is vertically down, so we take it negative. equals 0. Move Fg to the other side, so you get T cosine theta equals Fg. We call this equation 2. Now I'm going to divide equation 1 and 2. We will divide equation 1 with equation 2. So that gives me T sine theta over T cosine theta to be equal to Fe over Fg. You can cancel off the common terms here. I can cancel T and T. We also know that sine theta over cosine theta is tan theta. That is equal to Fe over Fg. Now we know that electrostatic force between two charged objects can be written as K Q1 Q2 over R squared. And since both balls have the same charge, we can write this as K Q squared over R, which is the distance between them. Here, the distance between the two balls is D. So I will replace R with D squared. Also, force due to gravity Fg can be written as m into g. We will substitute these two expression of forces here in our equation. So I get tan theta to be equal to Fe is kq squared over d squared and Fg is m into g. I want to calculate m. So I can rearrange my term. I will move m on the top here and bring tan theta down. We are going to swap them or cross multiply them. So that way we get m equals kq squared over d square g tan theta. I know all the values over here except the value for d, as they have not given that to me in the question. But we can find d by using the figure over here. If I redraw my figure, I get something like this. The two ropes, the distance d between them, and the angle theta. So this distance, this small distance here is d by 2, whereas I have the length of the string. I know that theta is opposite to d by 2. So I can use sine theta to be equal to opposite side over the hypotenuse. Opposite side here is d by 2 and hypotenuse is the length L. Rearranging the terms, I get d to be equal to 2L sine theta. I will substitute this in my expression for mass. And when you do that, you can rewrite the expression for mass m as kq squared over d squared. So I'm going to take square of this term, 2L sine theta squared g tan theta. Now I can substitute all the values to solve for mass m. We get mass m equals K, which is 9 times 10 to the power 9, Q, which is 25 microcoulomb squared over 2 times the length of the string is 1.50 sine the angle theta is 25 squared g is 9.81 times tan of the angle 25. And when you solve this, you get mass of each ball to be equal to 0.764 kilogram. Now, instead of rearranging the terms, you can also use shift solve at this point here. But you will still have to replace for d as 2L sine theta. And after you substitute all the values, you can still get the value of mass m as 0.764 kilogram.